Hey guys, these are the notes for parent functions in Unit 2. These are our first set of notes. Our essential question is, what are the parent functions and how can knowing them be useful? So in algebra, we have 7 parent functions total, but we learned 3 of them in Algebra 1, which are the linear, quadratic, and exponential function. But before we go over those 3 specific functions, we're going to go over what a parent function is. So a parent function is the most basic function. There's no other way for me to say this other than saying basic. It's the bare bones. There's no bells and whistles, nothing fancy. So we don't want any extra numbers that are in there or anything like that. So it's the basic minimum that a function needs to exist to be that type. So we have our 3 here, which are linear, quadratic, and exponential. And just to kind of give you a preview into the rest of the year, we are currently in Unit 2, which is an introduction to the rest. But linear functions, we'll be working with those in Units 3, 4, and 5. Quadratic functions, we'll deal with those in Units 6 and 7. And then exponential in Unit 8. Unit 8 is also our shortest unit. We don't spend very much time in it. Okay, so we have our linear function, so I'll go ahead and define what that is. So this is a first degree polynomial, but I'm going to go ahead and just say first degree function. So back in Unit 1, when we talk about degrees, degree is the highest exponent in that problem. So for example, when we saw something that was a 5th degree or a 7th degree, it means the highest exponent would be a 5 if it was a 5th degree. A 7th degree would mean the highest exponent is a 7. So if I say something is a first degree, the highest exponent we're going to have here is a 1. Now remember, in math, when the highest exponent is a 1, like for example in 3x, we don't typically write the highest exponent, which is a 1 there. We just leave it off. So just be aware that the 1 won't be written, but it is technically there. It is also a straight line. So if the line is not straight, then it's not a line. So I hope that's pretty explanatory. Also, linear, the key word there is the word line. So when you're seeing that you're talking about a linear function, hopefully you understand, oh, I'm going to be graphing a line here because linear means line. All right, so there's 4 types of lines that you'll see in math. So the first one is a positive line where it starts off at the bottom and it goes up high to the top. So it's a positive line here. And lines that have arrows on both ends, what does that even mean? So arrows mean that it extends in both directions forever and ever and for an indefinite amount. It just means that we don't have a line that stops. If a line did stop, then it would have points on both ends that would tell you, hey, it stops there, there's a halt. Now we also have negative lines that start high up and go downwards. And then we have horizontal lines that go side to side, left to right, and vertical lines that go up and down. So those are our 4 types of lines that we'll see when we're talking about linear functions. The next function we talk about is the quadratic function. This is a second degree function. And by second degree means the highest exponent we'll have here is a 2. If the highest exponent is not a 2 and it is a 1, then it's automatically linear. If the highest exponent is not a 2 and it's like a 5, then it's not a quadratic. So it has to be that its highest exponent is 2 to make it a quadratic. Now a quadratic function is a parabola. So let's talk about what a parabola is. Parabola is just a fancy word to say that something is the shape of a U. That's basically what that means. We give it a special name to say, hey, it's in the fancy shape of a U, but it's not really, we can't really call it a U shape, so we call it parabola. You'll also hear it be called parabolic. So if it's a parabolic function, it's the same thing as a quadratic function. So quadratic is the name of the function, but parabola is the shape that it makes. So parabolas, we have 2 types of parabolas that we work with, or quadratics. The first one is ones that open upwards. So it's like a U shape that opens up and it has arrows on both ends at the top. Or you'll have quadratics that face down, where the arrows are facing downwards, that goes forever downwards. All right. And then lastly, we have exponential functions, which are the last function that we deal with in algebra, or in Algebra 1. And exponential functions are functions where the exponent is a variable. So the key word here in exponential is the word exponent. So that gives us a little sign that says, hey, the exponent is going to be something that's important here. The exponent, yes, it's going to be a variable. So typically when we have exponents, it's like x to the 7th, or y to the 3rd, or z to the 4th. So our exponents are 7, or 3, and a 4 here. Our exponents are numbers. Well, in exponential functions, your exponents are not numbers, they're actually variables. And the variable that we're going to use is going to be x. All right. So I wanted to go ahead and give you 2 graphs that look like that. So in Algebra 1, our exponential functions, they'll kind of start off flat on the left, and then they'll shoot up really fast on the right. So it increases super fast and rapidly, and it goes positive. It's a positive growth here. The opposite we have is where it starts off pretty high, and then it goes downwards and kind of flattens off to the right. This is called a decay. And both of these are used, obviously, in real life as well, so as quadratics and as well as linear. But I feel like exponentials and quadratics are used a little bit more often in real life. All right, our next 4 vocabulary words are x-intercept, y-intercept, domain, and range. Now you'll notice with x-intercept, I have the word 0 next to it. 0 in math is also another word to say x-intercept. So if you're asked to find the 0 of something, you're asked to find the x-intercept of that function. But there's also 2 other words that mean that as well. The word root also means x-intercept. So if I ask you to find the root of the function, that means find the x-intercept. If I ask you to find the 0 of the function, find the x-intercept. The last one, which is the trickiest one for people to remember, is the word solution. If I ask you to find the solution of the function, it also means to find the x-intercept. But that doesn't always click because solution sometimes also means answer. So it's very confusing, especially in a math class when solution has meant answer our entire lives, and then all of a sudden, oh, solutions also mean x-intercepts. So just read the context of the problem. If the problem is giving you a graph and it says to find the solution, then they probably want you to find the x-intercept. But all 4 of these words mean the exact same thing, x-intercept. So what is an x-intercept? An x-intercept is where the function crosses the x-axis. So an x-intercept is going to be a point located on the x-axis somewhere. Now remember, your x-axis is your horizontal one, this one right here. So points that land here are considered an x-intercept, or a root, or a 0, or a solution. And just keep in mind, I say where the function crosses the x-axis because it's not always a line. Some people want to say, oh, it's where the line crosses the x-axis, but it's not always a line. So just be very mindful and you be very generic when you give definitions like that. Our next word is y-intercept, which is basically like an x-intercept, except this is where the function crosses the y-axis. Hopefully my spelling and my handwriting has been legible. I just realized my wheres look really terrible. Let me fix that. Where? Cool. Where the function crosses the y-axis. Now, there are no other words for y-intercepts, so that's actually pretty nice. Later on, when we talk about y-intercepts, they have a different meaning, but you're never going to really be asked to be like, hey, what's the other word for y-intercept? So y-intercepts are also known as your starting amount or your starting value as well, but we'll get more into that when we get later into other units. Our last 2 words on this page are domain and range. So domain and range are 2 tricky words because we often forget which one it's associated with. So in math, we have 2 variables that we use when we're graphing functions. We use x and we use y. So domain is always associated with your variable x. Always, 100%. Domain is never going to be associated with y. So when I say find the domain, I want you to basically list or find all possible x values. Okay, you want to find all possible x values. I need to fix this. Oops, I am so sorry. I'm not happy with that update. Okay. All possible, whoops, x values. And then range is basically the same exact thing, but range is dealing with your y values. So when you're asked to find the range, it's basically finding or listing all your possible y values.